Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 2 in the command injection module titled Blind OS Command Injection with Time Delays. Alright, before we continue with the video, I'm happy to announce that today's video is sponsored by hackersacademy.com. Hackers Academy is an online learning platform for individuals that are looking to become ethical hackers or security experts. It contains a ton of courses that cover a variety of topics like Wi-Fi cracking, privilege escalation for Windows and Linux, and introductory courses for how to get into pen testing. This video specifically is sponsored by the Hacking Fundamentals Bundle, which contains 2 amazing courses that teach you how to get into pen testing. The first one is the Hacking with Kali Linux course, which introduces you to the Kali Linux operating system. This was the perfect course to sponsor during the command injection module because while we're solving the labs, you'll see me run Linux system commands like whoami, ifconfig, netstat, and so on. And if you're not familiar with Linux systems, then this is a great course to take to familiarize yourself with how Linux works and how to use the command line in Linux. The second course is the Hacking for Beginners course, which teaches you all the fundamentals you need to start pen testing. This starts off with fundamentals like networking basics and goes all the way to things like scanning the network, identifying vulnerabilities, and then learning how to exploit those vulnerabilities. These courses already have over 60,000 students enrolled in them with nothing but amazing feedback. So if you're interested in enrolling in the Hacking Fundamentals Bundle, use the link on the screen or in the description of the video. The bundle is valued at $97, but as a special discount for our viewers, you can get it for less than $30, which is an amazing deal, so make sure to check them out. Alright, enough about our sponsor. Let's go back to talking about command injection. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Go down, select the learning path, go down, select command injection, and then go down one more time and select lab number 2 titled Blind OS Command Injection with Time Delays. Alright, let's get started. This lab contains a blind OS command injection vulnerability in the feedback function. The application executes a shell command containing the user supplied details. The output from the command is not returned in the response, so we can't use the same technique that we used in the previous lab because the raw output of the command is not displayed to us in the response, and so we're going to have to use a different technique. To solve the lab, exploit the blind OS command injection vulnerability to cause a 10-second delay. Alright, so because it's a blind command injection, the way we're going to prove that we do have a command injection vulnerability is by making the application wait for 10 seconds before it gives us a response. So the target goal over here is to exploit the blind command injection in the feedback function. Alright, let's access the lab. And while we do that, let's open up Burp Community Edition. Hit OK. Hit Next. Start burp. And let's close this over here and put it right over here. Okay. Set Foxy Proxy to intercept requests in burp. And let's click on the submit feedback page and it gets intercepted in burp. Turn intercept to off and go to HTTP history. Okay, let's submit a feedback form. So let's say test.test.ca, and then subject is also test, and the message is test. Hit submit feedback. And you'll notice over here that the response from the feedback form is just thank you for submitting the feedback. So it doesn't actually give you the response of the request that you performed. Instead, it just gives you a generic response. And so if any of these fields is vulnerable to command injection, it's not going to be an in-band command injection. It's going to be a blind command injection. So let's look at the post request that is getting performed and send it to repeater. Okay, so notice over here we've got a CSRF parameter, and then we've got the parameters that we saw on the page, which is name, email, subject, and message. Now, I don't know yet which field is vulnerable to command injection, and so I'm just going to start with the first one, which is the name field, and see if it's vulnerable. And the way we're going to do that is we're going to use the sleep command. So if you've never seen the sleep command over here, it essentially just tells the command line, sleep for a certain amount of time, and then run the command. So let's say over here, if I say sleep 10, it'll sleep for 10 seconds. And then when the 10 seconds are up, it'll execute the command. Okay, so it outputted the command. So over here, if you just say sleep 1, it'll output it automatically. So that's what essentially we're going to do in order to find if it's vulnerable to command injection. So we'll start off with the name field over here. So we're just going to say and sleep 10, and we're going to use the hash sign. So the and sign is just to concatenate two commands together, and then the hash sign over here is just to comment out the rest of the command so that we don't run into any errors. So let's highlight this and then Control U to URL encode it, hit send, and notice that we get the request almost right away, which means that the name field is not vulnerable to command injection. So let's remove this right over here and move on to the email field. So again, let's say and sleep 10, and then comment out the rest of the command. Let's Control U to URL encode it, hit send. And if it takes 10 seconds, so it's already taking an unusually long time, which means that I'm sure that this parameter over here, the email field, is definitely vulnerable to command injection. And here we go. So we get our output almost 10 seconds later. So a little over 10 seconds later. And you could see over here, it says, congratulations, you solved the lab. So you were able to prove over here that the email field is vulnerable to a blind command injection vulnerability. Now in the next lab, we'll see how we could use that in order to exfiltrate data from the system. But for now, the next thing that we're going to do is script the exploit. And again, the reason we do that, if you're new to this channel, is because I'm a strong believer that in order for you to be a great pen tester, you need to learn how to code, not full-on coding, but just scripting so that you could write your own automated tools. And that's what we're doing in these videos. So the first thing I'm going to do is import the requests library, because that's what allows me to perform HTTP requests, and then the sys library, which takes in commands from the command line, and the URL lib3 library. I'm also going to import, so I'm going to say from BS4, and I'm going to import the beautiful soup library. And what that's going to do, it's going to allow me to parse the response from the request and extract the CSRF token. Because notice over here, I'm seeing that there's a CSRF token that gets passed in requests. And so if I perform this request in my script without extracting the CSRF token first, it's going to tell me that it's missing a CSRF token. So let's remove it over here and prove that. Hit send. And here we go, it says missing parameter CSRF. And that's why I need to use the beautiful soup library to parse the previous response, extract the CSRF token, and then use it in this request over here. And you'll see that in a bit. Okay, next I'm going to use the URL lib3 library in order to disable warnings. This is so that I don't get warnings for using insecure TLS certificates. So let's say exceptions, .insecure request warning. And then I'm going to set my proxy settings so that every request I make in the script gets sent through my burp proxy first before it gets sent to the application, and any response I get from the application gets sent to burp before it gets sent to my script. And the reason I do that is because I'd like to debug my script in case it doesn't work the way I intended for it to work. So let's say 8080 and then HTTPS. And again, set that to burp proxy, which is running on 127.0.0.1 and on 8080. Okay, this looks good. Next, let's say if name is equal to main, call the main method. And then we're going to define the main method. So we're going to say if the length of the arguments of the script is not equal to 2, then print the usage instructions. So if a user runs the script with incorrect arguments, then instead of outputting an error, I want to output the usage instructions so that the user knows how to run the script. So name of the script and then just the URL of the application that you want to exploit. So again, let's give it the name of the script over here. And then we're going to print example instructions. So example, we're going to say www.example.com. And again, name of the script. And I'm noticing an error over here. It should have a bracket. And we should remove this bracket from over here. Okay, this looks good. And then terminate the script because it was run incorrectly. Alright, so assuming that the user runs the script correctly, what we're going to do is we're going to take in the command line argument, and that's the first one, and save it in a variable called URL. And then we're going to print checking if email parameter is vulnerable to time-based command injection. So we don't know yet if it's vulnerable, and so we're just checking to see if it is. And then next what we're going to do is we're going to say s is equal to request.sessions. And the reason we can't just make a request is we need to persist the session, because what we're going to do is we're first going to load the main page, extract the CSRF token from the main page, and then submit the request using that CSRF token. And sessions over here allows us to do that. Next, we're going to run a command called check command injection, which takes in the s variable and the URL of the application. Okay, and what this function is going to do is it's going to check if it's vulnerable to time-based command injection. All right, let's implement this function. So check command injection, again, it takes in the s variable and the URL. Next, we're going to add the path of the submit feedback page. So submit feedback path, and that's right over here. So let's copy this and put it in here. And then we're going to say our command injection is equal to this variable right over here, so test.test.ca. And then we're going to say and sleep for 10 seconds. And then we need our CSRF token. So again, we need to be able to extract the CSRF token. So if we go back over here, hit send again, it timed out, but the idea over here is that you need a CSRF token in the request in order for it to work. And so the way we're going to do that is we're going to extract it, and instead of implementing it in this function, I'm just going to create a new function for it. So the function is going to be called get CSRF token, and it's going to take in the s variable and the URL variable. Now we'll write this in a bit, but for now, let's complete this function over here. So we're going to say data, which is the parameters that the request takes. The first one is CSRF, and the value of that is going to be this variable over here, so CSRF token. The second variable over here is going to be name. So let's say name. And again, this one doesn't really matter, so we're just going to say test. The third variable is email. So let's add that over here. And the value of email is going to be the command injection variable, because that's a parameter that is vulnerable to command injection. And then the next parameter is subject. So let's add that. And again, we'll just add test right over here. And then the last one is message. So we're going to add that. And again, just say test right over here. So these are the parameters of the request. Now let's perform the request. So we're going to say s.post, and we're using a post method because you could see over here, it's a post method that is used in order to perform the request. And then we're going to say the URL is URL plus submit feedback path. The parameters it takes are in the data variable, which is this one right over here. And then I'm going to set verify to be equal to false because I don't want to verify TLS certificates, and I'm going to set proxies to be equal to proxies because I want the request to get passed through my burp proxy just in case my script doesn't run correctly and I want to know why it's not running correctly. All right, this looks good. Next, what we're going to do is we're going to say if the response time is bigger or equal than 10 seconds. So if it's bigger or equal to 10 seconds, that means we successfully exploited the command injection. And if it's not, that means we didn't successfully exploit the command injection, or maybe the variable is not vulnerable to command injection. So let's print it and say email field vulnerable to time-based command injection. And the reason we're printing that again is because the response time from the request that we performed is bigger than or equal to 10 seconds. Now, if it wasn't, so in our else field over here, we're going to print, or else clause over here, we're going to print email field not vulnerable to time-based command injection. All right, this looks good. So let's save this. Now we're still missing one function over here, which is how to extract the CSRF token. So let's write that right above it. So CSRF, get CSRF token. And again, it takes in S and URL as parameters. We're going to give it the feedback path, which is just equal to feedback. So if we go back to proxy, you could see over here the first request that is performed is feedback, and then it's feedback submit. So that's what we're doing right over here. We'll first perform the main request, extract the CSRF token, and then perform the request that exploits the SQL injection. So let's say R is equal to s.get, and it's a get request again, because if you go to proxy and you go over here, it's a get request that is being performed. So we're going to say URL plus feedback path. Again, verify is equal to false. I don't want to verify TLS certificates, and proxies is equal to proxies so that the request goes through my burp proxy. Next, I'm going to set soup to be equal to beautiful soup and the response of the text, and I'm going to parse the response. Once I've parsed the response, I'm going to say CSRF token is equal to soup.find, and I'm going to look for the first input variable. For the first input string and the content of the value field. So if we go over here, let's send this to repeater. Hopefully it didn't time out because we've been writing a script for a while right now. Hit send, and it did time out. So unfortunately, we're going to have to run this one more time. So open link in new tab. Go to submit feedback. And we'll see that in the history. So if we go over here, send this to repeater, hit send again, and let's look for the input variable. So the first one over here you could see is the CSRF one. So you could see what we want is the value of the CSRF variable. And that'll extract it right over here. So we're going to return CSRF. Now when this function runs, it'll return it right over here, and then it'll be saved in CSRF token, and it'll be used in the request to perform a command injection. So let's save this. Hopefully there's no errors. Run terminal, new terminal, and then just run the script. So Python 3 command injection lab02.py and the URL of the application. So just go to the home page copy the URL, put it right over here. And before we run our script, let's open up Burp and go to history. So you should see the request pass through the history tab. So hit send, and we have an error. So if we go right over here, it's because this should be this character over here, not a comma. So let's clear this and then run it again. And I have another error. This is what happens when you don't check your script. So it's on line number 21. And again, this should not be a comma. Hopefully that's the last error. Okay, perfect. So you could see over here it's making the feedback request. So it's checking if the email parameter is vulnerable to command injection, and it's performing the request over here. So it's extracted the CSRF token. It performed the request. It took about 10 seconds for it to run. So I don't know if that's displayed right over here, but you could compare the time from the time it ran versus the time that it took for it to run. So it took bigger than or equal to 10 seconds, and so it outputted email field is vulnerable to time-based command injection. Alright, so we successfully completed the exercise by first exploiting a time-based command injection manually and then scripting it in Python. In the next lab, we're going to see how we can take this blind command injection a step further and extract data from the application. If you liked the video, hit the subscribe and share button so that the video reaches a wider audience. Also, make sure to check out my course if you're interested in seeing more videos like this one. Thank you, and see you in the next video.